Welcome back to part 2 of the foot progression angles video. Let's go over the code from last time just quickly. So add the BTK to the path and then grab, let's see, 2 trials here. Filter, kinetic, kinematic, resample the data, support phase, foot strike and toe off. And then let's just keep the first value of foot strike and toe off. Run that. This was when we partitioned the data and just kept the jump ID and got rid of the .c3d at the end. And then this is where we made a structure, a dynamic structure with our 2 trials. And then what we have left to do is just go ahead and plot this data. So let's go figure 1. Let's create a for loop since we have 2 trials, therefore we need to do a subplot. So let's do 1 through file list number, and this subplot is going to be, let's see, we want 1 row and we want the number of columns to change based on the amount of trials that we pull in. And then this is where we plot our FBA, which is okay. Let me just run this first. Perfect. So we want the FBA. Okay, so instead of this, let's put field names and then squiggly bracket, let's do jump. And we have to close this, and then we want the foot angles of the left side. Let's do the left side first. And then we want this to be a black line with a line width of 2. Great, so this should work. If I just run it. Okay, so trial 4 and then trial 6. Let's see, subtitles. Since we have these names, let's just put those subtitles up, and then let's turn this property on for the subtitles. Okay, so far so good. Now this is when we would want to plot our foot strike and toe off. So let's do left side of the foot strike. We do the left side and we just copy this. And since we're using a for loop, we're going to use that iteration jump. And then I believe we could just copy this. So this is our x that we're trying to plot. And then our y is going to be not the entire thing, but it's going to be the angle at this index. And so I'm just going to copy this again. I'm going to place it right here. And then let's say that we want red circles. And this is going to mark our foot strike. Marker size, let's make this an 8 so that way we can see it. And then let's do a marker face color. Let's make that one red. Okay, so if I run this, we get this. So this is the angle at which the foot strike occurred. Could do the same exact thing with the toe off. Let's paste it in. And then let's make this green so that way we can differentiate well between the two of them. Leave the marker size to be the same. And then here we go. Okay. Let's fix the labels, so the X label and the Y label. So what we could do is, let's see if this works. X label. Let's do frames for the X label. And then the Y label is going to be our foot angles. And since this is in degrees, let's do this. Okay, so that worked. Let's repeat the same process for the right side. So now let's do figure number 2. And then everywhere we see left, we'll just do right. Just copy this. Right. I believe this is a small r. And then I'm just going to paste this everywhere. Trying to make sure I'm not missing anything. Okay, looks good. Let's give it a title. Let's see, the top one is, I believe, left foot. Let's say PIG, short for plug-in gate. And let's say FPA, for foot progression angles. I'm going to copy this, and then I'm going to go down here. And I'm just going to change this to right. And if I run this, there we go. So we have our right foot as well as our left foot progression angles. Now this looks good, but it could be improved. And I don't know if you remember the very first video at the very beginning when I talked about setting these thresholds, but what I mean by these thresholds is that, let's say that you're the experimenter and you want your subjects to land for these jumps, or I don't know, let's say that you have a gait analysis that you're trying to perform with your subjects and you need them to land with a certain foot progression angles. So like toes in, toes out. And let's say that you want them to land with a neutral foot, which is what these two trials are. And that would mean 0, right? You've got no angles in or out between your feet. Your feet are parallel. But it's impossible to always hit a 0. So what we want is to be able to give our subjects a little bit of leeway. So let's say that leeway is about 10 degrees. Okay? And what that means is we want them to land at 0, but we're willing to accept the trial as long as it's 5 degrees extra in either direction, so toes in or toes out. And those two are expressed as negative angles for the toes out in plug-in gait, and for toes in it's positive angles. So pigeon-toed, anything pigeon-toed for foot progression angles will be deemed as a positive angle. Okay, so now what we have to do is, let's see, thresholds underscore jump. Okay, so let's initiate this variable thresholds underscore jump, and then let's say if, let's see, if we go to file list, this is where we have our C3D files. So let's tell it if it contains if the file list contains a drop jump underscore n, then let's set this threshold equal to, let's make this vector 0, -5, and then +5. Okay. Toes out. Okay, now let's say that beside the condition of neutral position, so drop jump underscore n, you also have them land with toes out as well as toes in. And let's say that you want them to land with 15 degrees in each direction. So what you would do is you would do else if contains file list and then let's say dj underscore I. Let's say this is the one for toes in. And then again, we have to set the threshold here. And let's say that, let's see, 15 degrees is like 15 degrees in. And we want to give them the exact same amount of leeway, so 10 degrees, so 10 degrees in each direction, meaning this 15 degrees would become a 10, so less in than what we absolutely wanted, which is 15, and the maximum would be 20. And then let's say that you also have a toes out condition. And for this toes out condition, you want them to absolutely land at 15 degrees, negative 15, right? Because that's the external rotation, the duck foot. But then the most out they could land would be negative 20, and the least would be negative 10. Okay, this looks good. Now let me run this, and as you can see, the threshold is set to 0. Okay, so now what we would do is create a bunch of Y lines. And this part is really simple. So we want a Y line that shows the threshold. I meant to copy this. And we want the first value, that's the absolute value that we want them to land in. And we want to make that green. Okay. So now let me run this so you can see what I'm talking about. So this is what we just plotted, right? We want them to land at 0 degrees. Okay. But of course they can't always land at 0 degrees. Let's go ahead and plot the second and third value in the thresholds. So that way we're creating a border around our absolute value. And then let's go ahead and make these red. And then run it. And this is what you get. So what we're doing here is we're saying we want them to land, we want them to land at 0. But obviously they're not going to be able to always land at 0, like feet completely neutral. And as long as they're within this border, they're good to go. So now let's say that you want to check multiple trials. So I'm going to grab 1, 4, and 6. And this is what you get. So this is a quick way to kind of screen for this experiment. And you know, you can clearly tell, oh, all of these checked out. This one was almost perfect. This one was a little bit off, but still within the boundary, so it's still acceptable. And then you could do the same exact thing for the right side, and you can tell that all of these passed. I hope that you found this video helpful. If you have any questions, concerns, feedback, do comment below, and I'll be sure to get back to you.